Hi all, once again I welcome all of you on behalf of Ridgeway and PSK online classes. I hope that all of you studied what we discussed in last classes. Definitely we know in last class what we discussed regarding the Rutherford model of atom. I hope that all of you are familiar with, and now we need to go ahead with our next topic, like what is the drawback and what is the other models. Okay, so let's go with that. I think all of you remember what we discussed in last class. We are discussing about Rutherford model of atom. See, I have shown the picture over here and we discussed regarding this slide in last class itself. And what are the important postulates over there? First point, so definitely you are familiar with, most of the space inside the atom is empty. So first point, don't forget this, most of the space inside the atom is empty. And what is the second point? There is a small positive charge center, and what we call for this? We call this as nucleus. So we call this as nucleus, isn't it? And compared to the size of the atom, size of the nucleus is very small. See, if you are considering atom just like a cricket ground, the size of the nucleus is comparable to the size of a ball. Or you can write that radius of an atom is of the order 10 raised to minus 10 meter, whereas radius of nucleus is of the order 10 raised to minus 15 meter. You see, how about the size difference? See, whenever you are comparing the radius of nucleus and radius of an atom, you can see that about 1 lakh times greater size atom has compared with the nucleus, isn't it? Now, not only this, he predicted the radius of a nucleus of different atom. Let's see what is the equation given by him. I think I said already regarding this in last class. So what is that? Let me write here. Radius of a nucleus is equal to R0 into A raised to 1 by 3. And what is this A? A is mass number. So don't forget that. A is mass number. Still we need to discuss about mass number. Definitely after short time we will be talking about mass number. Okay. Now listen. See what I have written here. Radius of nucleus is equal to R0 into A raised to 1 by 3. As I told you in last class, listen all of you, we know what is the value of R0. R0 is equal to 1.33 Fermi. See, 1.33 Fermi. You know what is Fermi? Fermi is just like meter, isn't it? So it's a unit of length. So what we can write there, Fermi is equal to 10 raised to minus 15 meter. So remember this. See, these are the statements what is said about, or these are the hypotheses made by Rutherford. Now let's see what is the drawback of this concept. See, what is the first drawback? If the electrons are revolving around the nucleus continuously, then obviously what will happen there? They will lose energy. See, if they lose energy, what will happen there? See, the electrons are revolving in this path, and if the electron revolve in this manner, continuously it is undergoing change in direction. So continuously it is undergoing change in acceleration, isn't it? So when it is continuously getting accelerated, it will lose energy. If it loses energy, ultimately what will happen? It will come and collide with the nucleus. It will collide with the nucleus. But in real practice, you can see that electrons are stable around the nucleus. Such collision with the nucleus is not happening in any case, isn't it? So Rutherford couldn't account for this, which means Rutherford couldn't explain the stability of electron around the nucleus. Not the point. What is the drawback of Rutherford model of atom? First point, he couldn't explain the stability of electron around the nucleus. Because see what is the problem? If the electron is revolving around the nucleus continuously, it will emit energy. If it emit energy continuously, then what will happen? At the end, it will collide with the nucleus. But such a scenario is not happening in real practice. So why that is not happening, that couldn't explained by Rutherford. This is first drawback. So remember all of you, first drawback, he couldn't explain stability of electron around the nucleus. That is the first drawback. Second drawback, he couldn't explain hydrogen spectrum. And let's see what is the drawback of a Rutherford model of atom. See, these 3 points are the drawback of Rutherford model of atom. First point, he could not explain the stability of an atom. Actually, you need to read like this: stability of electron around the nucleus. Stability of electron around the nucleus. Stability of electron around the nucleus. So that couldn't explained by Rutherford. First drawback. Second drawback, do not say anything about the arrangement of electrons in an atom. You know, you might have studied in lower class. Like we have a K shell, or we have a L shell, or we have a M shell, isn't it? And in K shell we can accommodate 2 electron, L shell we can accommodate 8 electron. See, such things we studied, but Rutherford couldn't give any of this kind. So that is another drawback. So first drawback, he couldn't explain the stability of electron around the nucleus. Second point, he didn't say anything about the arrangement of electrons. And third but most important point, it couldn't explain hydrogen spectrum. Then you may ask one question, what is hydrogen spectrum? Students, try to understand. Actually, we need to talk in detail regarding this. Definitely, I'll be talking about this hydrogen spectrum later on the session, isn't it? So all of you please mind here. See, we discussed about Rutherford model of atom, and we said about the drawback of this concept. Definitely, I hope that all of you are familiar with. So let's go with the next topic. Okay, all of you. So the next point, what we need to study, it's atomic number and mass number. See these two terms, atomic number and mass number. So remember one thing, I am not talking about mass, I am talking only about mass number. Mass and mass number is different. Okay, all of you? So please see to that. You have studied right now different concept regarding atom. Now let us assume our atom as one nucleus is there. And inside nucleus, we have a neutron and a proton. Please try to understand, all of you. These neutrons and protons are together called as nucleons. What do you call for this? Neutrons and protons together called as nucleons. So here we have a neutron, here we have a proton, isn't it? So this constitute our nucleus. And now around this we have a electron. Okay, all of you. So around this we have a electron. This is the concept what we have regarding an atom. Now let's see what is meant by this atomic number. Try to understand, all of you. Atomic number means it is the number of protons inside an atom. So what is atomic number? Don't forget, number of protons inside the atom. Next point. What is mass number? Mass number means number of proton plus whatever number of neutrons. Okay. See, in order to represent atomic number, we are using the term Z. So all of you please see to that. Atomic number is denoted by the term Z and mass number is denoted by A. Okay. So please just listen here. A is not for atomic number, A is for mass number, and Z for atomic number. And you know what is Z right now? Tell me, all of you. Z means atomic number. And how we get atomic number? It is obtained from the number of proton. And what is mass number? Mass number means number of proton plus number of neutron. Now listen, all of you. See, here if you want to find out number of protons, I can write those equation once again. Number of proton can be obtained from atomic number. Number of proton can be obtained from atomic number. And number of neutron. How we can get number of neutrons? Students, try to understand. It's the difference between mass number and atomic number. So I am just writing here A minus Z. A minus Z. A for mass number, Z for atomic number. Next, number of electron. See, number of electron. So we need to write number of electron equal Z minus charge of the species. Z minus charge of the species. See all of you, Z minus charge of the species. Suppose in case our species is neutral, then you can see that number of electron will be equal to Z only. Okay, so all of you are familiar with this equation. Let us practice few questions on this, then let's go ahead, because we need to talk about atoms, we need to talk about ions, we need to talk about molecules. Okay, so remember these three equations in your mind. What is the first one? Tell me all of you. Number of proton can be obtained from atomic number. Number of neutron can be obtained by taking the difference of mass number and atomic number. Number of electron can be obtained from Z minus charge. Okay, all of you, let's practice 2 or 3 problems. So let's practice few problems on this, but don't forget our equations. Okay, all of you. So what are those equations? I am writing once again here. Number of proton is equal to Z. First one. Next, number of neutron is equal to mass number minus atomic number. And number of electron, what is number of electron? We have a Z minus charge. Z minus charge. Okay, all of you. So first I am considering 2 neutral atoms where charge is equal to 0. See to that. I am just writing one. Calcium 20, 40. See the way how I wrote this species. 20 at the bottom and 40 I kept on top. Which we write on the bottom, it's called atomic number, and which we write on top, it's called mass number. So I can write from here, what is Z? Z is equal to 20. And what is mass number? Mass number is equal to 40. Okay, our question to find out number of proton, number of neutron and number of electron. First of all, number of proton. So what about number of proton? Number of proton is equal to Z, which is equal to 20. Which is equal to 20. And similarly, let's see to the number of neutron. So when we have number of neutron, we have A minus Z. You know, A for mass number and Z for atomic number. So I can write here, all of you see here, we have a 40 minus 20, which will be equals 20. Similarly, next we have a number of electron. Try to remember all of you, whenever we have a neutral species, its charge is 0. If charge is 0, number of electron is equal to atomic number. So I can write the last point, number of electron is equal to Z minus charge. But you know, charge is 0. So what I can write there, Z minus 0, which is equal to Z. What is the value of Z? Z already written there, 20. Okay, all of you. So I have shown one neutral atom. One more neutral atom let us consider, isn't it? See, I am just considering another example here. Lithium, 3 and 7. And you know what is the atomic number here? 3. What is the mass number there? 7. So I can just write atomic number Z is equal to 3 and mass number is equal to 7. Now, listen all of you. They are asking to find out number of proton, number of neutron and number of electron. See, I am just writing number of proton. Number of proton is nothing else atomic number, which is equal to 3. Similarly, number of neutron. What about number of neutron? Number of neutron is equal to mass number minus atomic number or atomic number minus mass number minus atomic number. So I can write A minus Z. So what do you get? A value is there already 7. Z value is there 3. So we get 7 minus 3 which is equal to 4. So remember, number of neutron is equal to 4 in that case. And this is also a chargeless species. In case of chargeless species, number of electron is equal to atomic number. So I can write number of electron is equal to Z minus charge. What is charge here? Charge is 0. So if charge is 0, I can write Z minus 0 which is equal to Z. What is Z value here? 3. So your answer is 3. So in this manner, you can find out the number of proton, number of neutron and number of electron of neutral species. And let me try with a charged species. Now let's consider a charged species. See, I have considered calcium 2 plus and aluminum 3 plus. And you know calcium atomic number and mass number. Try to understand all of you. So for calcium, what is atomic number? I can write here atomic number of calcium is 20. And what is its mass number? Mass number equals 40. Now our question is same, number of proton, number of neutron and number of electron. So listen all of you. First of all, we have a number of proton. Number of proton equal Z is equals 20. Similarly, number of neutron. What is number of neutron? A minus Z is equal to, as we studied earlier, 40 minus 20, which is equal to 20. Actually, these two we already practiced, really speaking. But now let's see what about the number of electron. There we get some slight difference. Let's see to that. Number of electrons. So I am just writing number of electron. Number of electron equal Z minus charge. See all of you, in this case charge is not 0. So we cannot straightly write number of electron equals Z. Okay all of you. So please try to understand, in this case charge is not 0. What is the value of charge? So you do that, the value of charge is plus 2. So value of charge is plus 2. So I can substitute the value here. Number of electron is equal to Z minus of plus 2, means Z minus 2. What is Z value? 20. So what I can do there? 20 minus 2, which will be equals 18. So in this case, we got the number of electron equals 18. Similarly, whenever you go ahead with aluminum 3 plus, you know what is the atomic number of aluminum and you know what is the mass number of aluminum. Okay, all of you, try to understand atomic number. Z is equal to, for aluminum, atomic number is 13. And what is its mass number? You can see that mass number is equal to 27. So Z equals 13 and mass number equals 27. Question again the same thing only. Number of proton, number of neutron, number of electron. So what to do there? Number of proton. Number of proton is equal to atomic number, which is equal to 13. Similarly, we have a number of neutron. What is number of neutron? So we have the equation over there. A minus Z. A is given already 27 and Z is 13. So I can write there 27 minus 13 is equal to 14. So number of neutron. But the important thing what we need to mind, number of electron. So what is number of electron? Number of electron is equal to Z minus charge. Z minus charge, isn't it? What is the charge here? 3 plus. Okay, all of you. Then let's substitute here Z minus 3. So we get atomic number is 13. 13 minus 3. So what is 13 minus 3? 13 minus 3 is equal to 10. So what we got the answer there? Tell me all of you. We have got 10. That is the number of electron in case of aluminum 3 plus. Okay, all of you. So I have done some problems on charged species, but these two are monatomic species. Suppose in case if we have a diatomic or triatomic, then if they comes, then how we will approach that problem, that we see next. See, here I had given not a monatomic species but a triatomic species. See to that, first one CO2, next one we have a N2O, and I am writing one more there, CO3 2 minus. It's a charged species, that's why included. Okay, all of you. So we have CO2, N2O, CO3 2 minus. Okay, let's start with CO2. What to do? Question is same only again. Find the number of proton, number of neutron and number of electron. What to do? See, in case of carbon dioxide, we know we have two type of atoms there. One is carbon, next is oxygen. But still, how we do the number of protons? Try to understand all of you, and please keep in mind number of proton. Earlier we wrote number of proton equals Z. But right now what we need to write, number of proton is equal to sigma of Z, means you need to add everything together. Okay. So number of proton is equal to sigma of Z. Don't forget all of you. So in this case, number of proton is equal to sigma of Z, means you need to add the atomic number of each and every atoms. We are doing that. See, here atomic number of first carbon. We know atomic number of carbon is 6. Next, we have not one oxygen, you have two oxygen. So you have to consider both the oxygen atom, isn't it? And you know, for one oxygen atom, atomic number is 8. We have two atoms there. So total we need to add 8 plus 8, 16. So I am adding that 8 plus 8. So ultimately 8 plus 8, 16. 16 plus 6, you got how much? 22. So you have got the answer here. All of you listen. In this case, you have got number of proton is equal to 22. Now, let's see what about number of neutron. Number of neutron. See, I have written the equation there, A minus Z. Okay. So as we studied earlier, we know number of neutron is equal to A minus Z. But right now, what the change we need to do there? Nothing else. Listen all of you. What to do there? Sigma of A minus sigma of Z. Sigma of A minus sigma of Z. Sigma of Z we already calculated and we kept there, it is 22. And let's check what is sigma of A. A means mass number. Sigma of A means sum of mass number of all the atoms present there. See, you know what are the atoms there? Carbon. What is the mass number of carbon? 12. So I can just write there number of neutron is equal to, okay, all of you, 12 plus 12. Whose mass number? Carbon mass number. Okay. Next, oxygen mass number. You know, definitely oxygen mass number 16. So how many oxygen there? 2 oxygen. So I can write 16 plus 16 minus sigma of Z. Sigma of Z is already there. So what is that? It's, sorry, here it is not equal, minus, isn't it? Then we will be getting 22 here. Okay, all of you. Now, what's the ultimate answer comes here? 12 plus 16 plus 16, you will get 44. So we have 44 minus 22, which is equal to, what will come there? Tell me all of you. Which will be equals 22. So you got the answer. So we have got number of protons 22, number of neutron 22, and this is a neutral species. For a neutral species, number of electron and number of proton is same. So I am not going to calculate that. And this one you have to solve yourself. Okay. And I am trying to solve the last one. Let's see how we need to solve that. See here we have a CO3 2 minus. You know what is the charge of that? It's 2 minus. I am not going to calculate number of protons. I am not going to calculate number of neutron. I am calculating number of electron. Let's see how we can find out number of electron. See, I am just writing the equation. Number of electron is equal to Z minus charge. That's what you wrote earlier. But right now you change that. Sigma of Z minus charge. Okay, all of you. Then you will be getting what is sigma of Z. We need to add the atomic number of all the atoms. You know, atomic number of carbon is 6, oxygen is 8. How many oxygen is there? 3 oxygen is there. Let's add together. So what I can do there? 6 for carbon. Next 8. It's for oxygen. But how many oxygen is there? 3 oxygen is there. So 8 into 3. Okay, all of you. The whole minus its charge. What is the charge? It's not 2. Charge is minus 2. So that minus 2 you have to substitute here. So what you have next? Minus 2. Then you will be getting the answer 6 plus 24, isn't it? Minus what comes? Minus of minus 2. Minus of minus 2 is plus 2. So ultimately what you get? 30 plus 2. 30 plus 2 is equal to 32. So the number of electron in that case it comes as 32. Okay, all of you. Students, try to understand what we discussed today. First of all, Rutherford model, recap. Then drawback of Rutherford model. And now we have studied two more concepts, atomic number, mass number, and from that how we can find out number of proton, number of neutron and number of electron. Okay, all of you. So let's see with the next topic on next session. Thank you all of you.